All right, here we go for the final section of our trig unit. We're going to be in section 9.8, and this one just gets into a couple formulas for adding and subtracting angles. Let me back up one page real quick to show you those. Good news is you're not going to have to memorize these. That's really not what this class is for. This class is for about applying these type of formulas. So this is what they're going to look like. So it's just about adding a couple or subtracting a couple angles. And we're just going to kind of dive right in here so I can show you how these work. So if I were asked to get the sine of negative 75 without a calculator, you'll notice 75 degrees is not a value that's on our unit circle. So as I look at our unit circle, you'll notice 75 would be somewhere in this area here, but since it's not one of these values, I couldn't do it without a calculator unless I apply one of these formulas for today. So today's going to be about just applying these formulas, and for this one, especially because it's our first one, we're going to change to a positive 75 because I just want to show you how these formulas work. So let's just change that guy to a positive so I can show you. So what we're looking for here is, since 75 is not on the unit circle, I need two angles that either add or subtract to make 75. So if you look at these two guys right here, I can add those two angles together, and they would add up to 75 degrees. And so these are the two angles I want to use. So instead of 75, I'm going to see it as the sine of 30 plus 45 degrees. And so that's what we're going to change this guy to. So let me jump over. So we're going to see this as the sine of 30 plus 45. And now that I am adding two angles, now I can jump into our formulas for today. So again, here's the adding for a sine, as you look right here. So it's sine A cosine B. So the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second one. So sine A cosine B. So let's just throw those guys in here real quick. So this is our angle A, and this is our angle B, right? So we're saying the sine of angle A times the cosine of angle B plus, and then we're just going to switch them. So now we're going to say the cosine of angle A times the sine of angle B. And all we have to do is plug in the information. So if we said, what's the sine of 30 degrees? So as you look at our unit circle, here's 30. You can see that the sine is 1/2, and the cosine is is just rad 3 over 2. So we said the sine is 1/2. The cosine of 30 is rad 3 over 2. And again, if you went back to that unit circle, the cosine at 45 degrees is your x coordinate. The sine is your y coordinate. And so we just have to simplify that expression right there. So multiply those guys together, I get rad 2 over 4. And multiply those, I get rad 6 over 4. And since they do have a common denominator, let's go ahead and put those together and call it rad 2 plus rad 6 all over 4. And that would be the best way to leave our answer. And that's it. So it's just a matter of finding some numbers that would add or subtract to give you that value. So if we look at 120, there we go. So if it's a value that does fit the unit circle, then of course we would not need a sum or difference formula for this one. So I'm going to change that 120 on our tangent. And let's get something in between instead. So let's say the tangent at 15 degrees. So I'm changing tangent 120 to tangent 15 for this problem. So it'll match up with the formula. If we said 120, we would just do our sine divided by our cosine, and that would be our answer. So instead, let's get a value that's not on here. So if we said 15, a couple ways you could do this. I could subtract 45 minus 30, and that would give me my 15. I could do 60 minus 45. That would also work. Any combination of making 15 is going to work for you. So I'm going to turn this into, and I'm just going to write it while I'm talking here. So I'm going to turn this into the tangent of 45 minus 30. So tangent of 45 minus 30. And then we're going to go from there. So Let me go back to our formula so you can see it. So for the tangent of 45 minus 30, formula is going to look like this. So this is our 45 degrees, and that's our 30 degrees. So tangent 45 minus tangent 30 over 1 plus tangent 45 tangent 30. So I'm just going to write that out, and we'll plug in. So tangent 45 minus tangent 30 over 1 plus tan 45 times the tangent of 30. And all we have to do now is plug in the values. So at 45 degrees, my tangent value is 1. And I'm going to do all these, but let me just show you. So again, at 45 degrees, tangent is always my sine divided by my cosine. So in this case, if I just divide those guys, I just get a value of 1. So my tangent at 45 is 1. My tangent at 30. So if I did this divided by this, I get 1 over the square root of 3, which if you rationalize that denominator becomes rad 3 over 3. And again, all that is not leaving the radical on bottom of your answer. So instead of leaving it as 1 over rad 3, I'm multiplying by the square root of 3 over the square root of 3 in order to rewrite it. So, and then below this, we're going to do 1 plus the tangent of 45 times the tangent of 30. So now I'm doing, let me focus. So down here, now I'm doing 1 plus the tangent of 45, which is 1, times the tangent of 30, which is 1 over the square root of 3, which we are going to write as this. And then so from here, I would just do a little simplifying. Let's get some common denominators. On top, think of this as 3 over 3. So I am going to do, actually, let me just say it this way. This will be easier. I'm going to multiply everything by 3, right? And that's going to clear out these denominators that you see right there. So I'm just going to distribute 3 to everything. And that gives us this. So we're okay to leave our answer like this. We can still say, well, there's an issue here because I'm still leaving a radical on bottom. So there is a way to get rid of that. The conjugate of this, if you just change the sign, becomes 3 minus the square root of 3. This is something that you would have done in Algebra 2, is multiply by a conjugate so that you don't leave that radical on bottom. And so now if I go through and distribute, I'm going to get my new setup without leaving a radical down there. So I'll do that real quick. So if I did 9 minus 3 rad 3 minus 3 rad 3, so 9 minus 6 rad 3. I multiply those together, it's plus 3. So I'm just doing FOIL to get that. And on bottom, as you FOIL, you're going to get 9 minus 3. So if I do a little cleanup on that, on top, those would come together to just be 12. So 12 minus 6 rad 3 over 6. And since 6 goes into everything, let's take one more step. Get this guy. All right, so let me jump down to 1 or 2 here involving pi instead of degrees. So we're going to kind of switch over to radians for this. So these can be a little tough because it can be hard to figure out which 2 angles add or subtract to be something like this when you're now dealing in terms of pi. You're going to need common denominators and all that fun stuff. So one option you do have, you can just change that to degrees and do the whole problem from there. So if I wanted to convert this to degrees, we would just multiply by 180 over pi, and we can convert that to degrees. So I'm going to do negative 7/12. Remember, these pi's cancel, so I'm just doing my negative 7/12 times, and instead of saying 180 over pi, I'm just going to say 180 because the pi's would cancel anyway. And so we're at negative 105 degrees. So we're going to see this as the cosine of negative 105. So again, 105 is not on the unit circle, so we need a couple angles. So if I go 105 is going to be somewhere in here. So if I'm going in the negative direction, that just means it's going to be somewhere in here, right? As I go negative 105, it's going to put me somewhere in this area right here. So a couple angles that could give me a negative 105. We could do negative 60 plus negative 45. So if I were to travel negative 60, that's going to be this guy. Negative 45. So instead of traveling right here, if I travel negative 45, it's going to be here. So I'm going to be looking at these two. So this is my negative 60, and this is my negative 45. So let me just write that while this is up here on the screen. So I'm rewriting mine as the cosine of negative 60 plus negative 45. And yes, you could write that as negative 60 minus 45 and turn it into a subtraction problem, but I think it's going to be more clear if I write it as negative 60 plus negative 45. So we can see it as a sum and clearly identify that my two angles are at negative 60 and negative 45. So if we go back to our cosine formula, let me flip you back to that one. So I am adding these two angles together. So the sum for a cosine, you can see right here, is going to be cosine A cosine B minus sine A sine B. So we're going to say cosine A cosine B minus sine A sine B. And that'll be that. The 45s are the simplest. Let me start with those. So remember on your circle here, this is positive 45 degrees. So if I go this way, it's negative 45 degrees. So I get the same values. Remember, from here to here, it's all the same values. It's just which ones are negative. If instead of going up, if I'm going down, my sine value becomes negative because I'm going down instead of up, right? So my cosine doesn't change because both of these still go to the right. So this one goes to the right and up. So it's positive, positive. This one goes to the right and down. So it's positive, negative, since I went down for this guy. So as far as the cosine of 45 is going to be a positive rad 2 over 2, and my sine is going to be negative. So I'm just going to start filling that stuff in here on my paper. So I got the cosine at negative 45 to be the positive, my sine at negative 45 to be the negative rad 2 over 2. So I'm just writing those on my paper. And then for the cosine at negative 60 and sine 60, remember it's the same as 60 degrees. It's the same numbers that you see right here, you're seeing right here. But again, my sine is now negative because we're going down instead of up. So I'm still looking at these values. So my cosine is going to be positive 1/2. My sine is going to be negative rad 3 over 2. So my cosine is 1/2. My sine is negative rad 3 over 2. So now we're just going to do a little cleanup here. So if I multiply those guys together, it just becomes rad 2 over 4. I'm dealing with 3 negatives, so overall this is going to be a negative outcome. So minus. As I multiply those together, I get rad 6 over 4. And again, common denominators, let's bring it together. I got rad 2 minus rad 6 all over 4. Okay, so let's jump on down to some other stuff here. So with these guys, we're going to have to do a little Pythagorean theorem to work with those. So my A angle, let's see, we can do, these are going to be kind of the same idea. So let me just do whichever one I think is hardest. We just did a cosine subtraction, and we've already done a sine addition as well. So I'm just going to pick one here. I think this one tends to be harder if it's cosine of subtraction. Oh, we did addition. So let me do a cosine of subtraction on this one. So I'll do my artwork over here. So if I had angle A, they're telling me right here is between pi and 3 pi over 2. So remember, this is pi, this is 3 pi over 2. So they're essentially just telling me that I'm in quadrant 3. So that's where I'm going to draw my triangle. I always connect it to the x-axis. We're calling this angle A. That's our reference angle. And for A, the sine value is negative 4/5. So remember, sine does opposite over hypotenuse. So opposite over hypotenuse. And of course, my negative would have to go with the guy that goes down. Anything that goes left or down is negative. Hypotenuse is never negative. If I did Pythagorean theorem on this, I get 3. And again, because this goes to the left, it's going to be negative. So that's our information for angle A. Angle B is in the first quadrant based on that information. So I'm going to draw angle B right there. So this will represent angle B. And again, the cosine is 5/13, so cosine does adjacent over hypotenuse. So adjacent over hypotenuse. If you did Pythagorean theorem, you get 12. Everything is positive because I'm in quadrant 1. So that's all the information we're going to need. So now I'm just throwing everything into our cosine difference formula, which is, if you look on the previous page, it's just going to be cosine A, cosine B. Let me just write it so you can see what I'm plugging in. Cosine A, cosine B plus sine A, sine B. So the cosine of A, here's angle A. Cosine does adjacent over hypotenuse. Cosine of B, which they've already told us is 5/13, but you can see it here as well, adjacent over hypotenuse. My sine of A, they told us right here was negative 4/5, and I can see that within my triangle as well. The one we had to find with the triangle was the sine of B. So from here, my sine would be opposite over hypotenuse, so 12/13. And so there's our setup, and I just got to do a little simplifying here. So see, 5 times 13 is 65, I believe, so negative 15/65. Right here, I'm looking at negative 48/65. And combine those guys together, we got common denominator, so nice and easy. I believe that is negative 63/65. And that would be our answer. So for these guys, obviously the benefit will just be making sure you draw the triangles. This information tells you what quadrant to draw it in so that you make sure you get all of your signs correct. So remember, anything that goes left or down is negative. But other than that, it's just plugging into that formula. And since you don't have to memorize the formula, this really shouldn't be too bad. So let me jump to the next page. That was just more of the same with tangent. You would be using the same 2 triangles. Just remember, tangent does opposite over adjacent, the whole SOHCAHTOA phrase. So we would just be plugging in numbers into our formula for a tangent as well. So I want to take you down to these guys so I can show you something that's a little different. So what do we get if I have the sine of an angle and I add pi halves to that? So take a look at our unit circle for a minute. So let's just say, so pi over 2 is like 90 degrees, right? So let's just say you're right here. Your sine is 0. If I add pi halves, that puts me up here at 1, right? But look what happened to the cosine value and the sine value. So if my sine value is 0, as I add pi halves to that, that same value, I'm now at the cosine value, right? And if I add another 90 degrees, I'm back to the sine value, add another 90, cosine value. So is where they are equal. So these are what we call complementary angles. We've talked about these before as angles add to 90 degrees, you get the other angle. So my sine value, if I add 90 degrees, becomes the cosine value, and vice versa. So for this first one, all we're looking at here is my sine at x plus pi halves would now bring me to the cosine of x. Right, and that's what we were seeing on that unit circle. Since I was starting at 0, where am I as I end at 0? I still want to keep that answer of 0. What about tangent? So if I'm at the tangent of x, what happens if I subtract 2 pi? Well, this is an easy one. You subtract 2 pi from anything, and it puts you right back to where you started. So my tangent, I'll just do like an easy one like right here. So tangent we know is sine over cosine. So sine over cosine is 1, right? If I subtract 2 pi, that just takes me one lap around the circle. I'm right back to where I started from. I'm in the exact same position. So as I add 2 pi to, or subtract 2 pi, either one, I'm still at the tangent of x. Right, no matter what angle I started with, x represents any angle on that unit circle. Right, if you subtract 2 pi, you're going to be right back to where you started. And that would be true with any of these. So you add or subtract 2 pi from anything, and you're right back to where you started. So that was just the cosine of x. 5 pi over 12, let's see what's going on here. Keep in mind this would be more than one lap around. Anytime, I'm going to rewrite this as a mixed number so you can see it more clearly. 5 pi over 2 is the same thing as 2.5. Right, that's what it's given us. In other words, I'm going to take 2 pi, which is one lap around the circle, plus another half a pi. And let's see what that gives us. Remember, we already talked about as I add pi halves, what happens, right? As you add pi halves, you're just going to be, as far as sine and cosine are concerned, you're just going to be on the other guy. So my cosine at any angle plus 2 pi and a half. So I'll just do it from, what's an easy one? We'll just do it right from here. So my cosine value is 1, which means I still need to have a value of 1 as I do this. So as I go 2 pi, puts me right back to where I started, plus another half a pi. And notice I still need a value of 1. So as I go another pi halves, puts me right here. Pi halves is just 90 degrees. And now I'm at the sine value of x equals 1. So as I went that 2.5 times around, I am now at the sine of x. Would give me that result. And let me take you down to one last piece here and we'll call it quits. So as I look at this, whenever we are missing an angle, remember that means like an inverse function. So essentially I'm looking at the inverse sine of 1 for this. Another way to say that would be the sine of what angle has a value of 1. Well, let's see. The sine of what angle has a value of 1? So right here at 90 degrees, or I'm going to keep this in terms of radians. So at pi over 2, I have a sine value of 1, and that's it. So right here at pi over 2 is where I would find that value. So as we look at this, let me get rid of that guy. So as I look at this, again, we're saying at pi over 2 is where I get this result. So my angle, which is x plus 3 pi over 2, is at pi halves. And so that just gives us the equation that we're setting up. On this, and this is kind of key to this, you'll notice that they want all of the answers between 0 and 2 pi. So first of all, because they said 0 and 2 pi, I'm writing my answer in radians. Also, they want this within, every answer within one positive unit circle. So as I solve this equation, and I subtract 3 pi over 2 from this, watch what we get. So if I subtract 3 pi over 2 from both sides, what does that give us? So 1 minus 3 is negative 2 over 2, so negative 2 pi over 2, which equals negative pi. So that is the right answer. However, we need this to be positive because this domain right here says they only want answers from 0 to 2 pi, and this is obviously negative. So how do we get this exact same value within the positive unit circle? So as I look at negative pi, so again, if I'm starting here, negative pi would be right there. So how do I get this exact same value? Well, if I just add 2 pi to this, it takes me one lap around, and now I'm in the positive unit circle at that same value, right? And so at our value of pi is where we get the same result, but now I'm in the positive unit circle. So all I had to do to this to turn it into a positive was add 2 pi to see where that puts me in my positive unit circle. Let's try one more of those. As I look at this, remember what we talked about up above? My value of sine, if I subtract or add 90 degrees, which is all this is, takes me to the other angle. So this is the same thing as saying the cosine of x plus, now what's this one going to be? Right? If my complementary angle to cosine is sine. So where do we get values where the cosine of an angle plus the sine of an angle is 0? So if I look at here, if I add those together, I get 1. So I'm looking for where's a case where if I add the cosine, which is the x, plus the y, I get 0. So if I add those together, I get 1. So look at right here. If I add those two angles, or if I add those two values together, so if I did my cosine, which is this, plus my sine, which is this, those guys add to 0. So is there anywhere else that would take place? So we know one of our answers is going to be 3 pi over 4. Where else would that take place? So as I go right here, I'm running into that same scenario. Sorry, my cosine plus my sine adds up to 0. So at 7 pi over 4 and at 3 pi over 4 is where I find those two solutions. So at 3 pi over 4 and at 7 pi over 4. And that's it for the final lesson.